Many technologies and applications require energy storage systems that can store and deliver large amounts of energy quickly. The power delivery is often more important than the amount of stored energy. In these situations, batteries are less efficient because they perform chemical reactions and thus have a relatively slow energy transfer. Supercapacitors are based on electrostatic charge separation and therefore show much faster charge-discharge cycles. Furthermore, supercapacitors have a higher power density and a significantly longer cycle life compared with batteries. Supercapacitors are today available as energy storage devices in various sizes, all the way from devices in electronic applications to parts in vehicle power supplies. However, their uses are hampered by their relatively high price. Conventional supercapacitors are produced using porous conductive substances as electrode material. For electrodes is paper. Paper can also be used as an ion-permeable separator in the middle of the supercapacitor.
So, what are the advantages of using paper as electrodes? First, papers can increase the capacitance, and they have the potential to produce supercapacitors to be more cost-effective. Papers are also considered thin and flexible. Papers are also cheap and easy to require every day. Next, paper usually consists of cellulose fiber. And cellulose is an important structural component of the primary cell wall of green plants, which are the most abundant renewable organic materials on Earth. Paper is also stemmed from cellulose fiber. With superior hydrophilicity, excellent mechanical properties, and flexibility, hence it is an ideal substrate for the flexible energy storage devices. Let's move on to the mechanism. First, the office waste paper was first treated with a simple of washing and activating process, then freeze drying will be taken. And paper fiber will produced from these. Graphene oxide, or short formed as GO, tend to be strongly anchored on the paper fiber surfaces and fill the pores of the PFs because of electrostatic interaction. Then the paper fiber reduced graphene oxide, also known as PFRGO, would be formed after the complex was reduced by reducing agent. Manganese dioxide, MnO2 nanowires were introduced into the complex under vigorous stirring in order to get a uniform dispersion. Paper fiber reduced graphene oxide manganese dioxide complex, which then becomes the electrode, was obtained after filtration and drying. There are optimum conditions for these mechanisms to occur. GO and MnO2 in PFRGO MnO2 composites are fixed at 24 weight percent and 20 weight percent respectively. RGO sheets also fill the voids between the paper fibers, which would be beneficial to further improve the conductivity of the hybrid electrodes. In this hybrid structure, the PF provide the flexible substrate. The MnO2 nanowires would endow the electrodes with high specific surface area and good electrochemical performance of the electrode. The electrochemical performance of the composite electrode was investigated by 3-electrode system, with 1 molarity of sodium sulfate as the electrolyte. While saturated columel electrode and platinum plate are being used as references. The high capacitances of the PFRGO MnO2 electrode are mainly from the double-layer capacitor of the RGO sheets and the pseudo-capacitance of MnO2 nanowires, while the PF only acts as a flexible substrate. The specific capacitances for the PFRGO MnO2 electrode is up to 410 farad per gram at a current density of 0.8 ampere per gram. And even with the discharge of current density of 10 ampere per gram, the specific capacitance is still as high as 210. So, as conclusion, the assembled solid-state symmetric supercapacitors exhibit high energy density, which is 19.6 watt-hour per kilogram at 400 watt per kilogram. The development of an alternative supercapacitor electrode material from waste paper serves two main purposes that are helps with waste disposal, which is converting waste to a useful product, and provides an economic argument for the substantiality of supercapacitor technology.